Okay, let's go. All right, topic 3. Let's just go back and remember topic 3. The goal was simple. Topic 3, we were going to use this table and simply keep track for any element, protons, neutrons, electrons, the Z and the A number. Since these 3 particles determine how an element behaves, it's important for us to keep track of those. That's what we do in chemistry. We keep track of them. So topic 3 was simple. Hey, I'm going to give you an element, and you're simply going to tell me how many protons, neutrons, electrons. That's it. Topic 4 is going to expand on topic 3. Okay? So watch how topic 3 turns into topic 4. What we do in topic 4 now is we look at what they call atomic mass, which, if you think back to topic 3, my friends, it was simply your red number. You're going to use red numbers all day today, but you're going to use them in different topics. So an example in topic 4, now using atomic mass. Yes, this is going to look very similar to topic 3, but now I'm going to focus only on mass and not protons and electrons and just neutrons. I want mass. And remember, the mass is the protons and the neutrons together. So an example. Let's say they pick gold. We all love gold. We all want more gold. You can give me all the gold you have. I don't care. We're going to use our table now, and we're going to figure out what is the atomic mass for gold. Which, yes, I know, this is easy, because it's just the beginning of topic 4. Hey, we just need to find this guy on the table. We need to get the red number and round it off. I'll save you some time. Gold's symbol is AU. Okay, I hope you all have your own table. If you don't have a table, it's going to get nasty for you. I don't know what you're going to do. I warned you, you need your own table next week. Well, next week is here. You're making the class much more difficult if you don't have a table. Okay, so table, gold sheet, or sorry, gold sheet. Hey, there it is right there. Hope you found AU using your table. I hope you grabbed that red number, and I hope you rounded it off. And when I do that, I get an atomic mass of, what was gold? What's that sucker? It's heavy. 197. What is the unit for that? Well, for now, we're simply going to call it AMU, which simply stands for atomic mass unit. Atomic mass, and it's a unit because we're simply counting the number of protons and neutrons. Later on, that's going to change to one of your favorite unit of measurements. Okay, that's it. That's the beginning of topic 4. Notice now, I'm not interested in the protons or just the electrons. I just want to know basically the A number right from the table. Just to see if you're with me so that you feel confident, would you please give me the atomic mass for, let's go selenium. Selenium. I didn't know there was an element named selenium. Yes, there is. His symbol is Se, and I'll give you a hint. Go to the right side of your table. The right side of your table. Find this nice dark zigzag line, and it's going to be over to the right. Hurry, locate. Get that red number. Round it. Selenium, there he is. Got that red number? Boy, I'm going to round that off because that 9 is going to bump up the... Hey, 79. And the unit would be AMU. Okay, so far so good. Easy. Why are they easy? They're just single elements all alone. And when they're single elements all alone, they'll use the words atomic mass. Well, unfortunately, in the world we live in, my favorite second period, like salt, sorry, salt is not simply one element. It's two combined together into a compound. So what we do now is we start grabbing compounds, but the goal is still the same. What's the mass? But they have to change the wording now. They have to change the wording. They can't use atomic mass. And so what they'll do now is they'll take out the word atomic and they'll put this in there. Molecular. We still want mass. And you should know by now, and from topic 3, that the mass always comes from the red number. All right, well, let's use good old table salt from my pantry. Now look at the difference. It's not just one element. Table salt is composed of 2. We have a sodium and a chlorine. I just need to get the red numbers and add them together for these two guys. Okay, watch this carefully because there's things you need to be aware of. Watch and listen to my steps that I take. The first thing I do is I find this guy on the table, I get his red number, and I round it. Now I'm going to speed up this process. I'm going to show you, hey, there he is. Get NA, get that red number, round it, and seeing that, I would go, 23. When it comes to compounds and molecular mass, boy, you guys better be careful now, because there might be some numbers that show up here in the lower right-hand corners. If you don't see any numbers, which this one doesn't have any numbers, you just assume that there's 1 there. There's only one NA. I'll show you where numbers start to show up, don't worry. So I only see 1 NA. That means his total is 23. Okay, let me get rid of this. Here, I'll just move it over here. Because what I gotta do now is I gotta find chlorine. Okay, again, listen to my steps. The first thing I do, I'm going to find chlorine on this table. There it is. Look at his red number. Look at his red number. Round it. 35. Cha-ching. Second thing, boy, I better know how many chlorines are in a compound or molecule of good old table salt. I don't see a number here like 2, 3, 4, 5, 22. They can be quite large. There's nothing there, which means really there's just 1. And I'll times it by 1. At least the math is nice and easy. This Na is worth 23. This Cl is worth 35. My friends, I need a total. I need a total. I simply add them up together and I get a total of 58. And so you would say, hey, Sticks, the molecular mass for table salt is 58 AMUs. Questions? Let me show you now where numbers show up in these corners and how you attack that. To show you one of those, I need to get rid of all this. I need to get rid of this. I need to get rid of this. Okay, so let me go back up here now. It's still under atomic mass. So example 1. All right, so let's say that you had this substance now. And the question was, all right, well, what's the molecular mass? Molecular mass. Hey, you got some potassium nitrate, one of the main ingredients in gunpowder. Woohoo, let's go explode things. No, we're not. All right? Ah, there it is. That's what I'm talking about. Let's see how this plays a role in the total mass of this compound. Again, watch my steps, my friends. First thing I do, I grab my table. I find K. His name is potassium. I get his red number, and I round it. Boom. There it is, 39. Second thing I do, you better go back and look. How many Ks or potassiums are in here? Well, I don't see a number to the lower right-hand corner. That tells me there's only one there. Total for him, 39. Nitrogen. Boom, right off the bat, man. I go right to the table. I locate red number, round it, simple, 14. Second thing, you better find out how many nitrogens are in this compound. I don't see a number to the lower right. That tells me there's only one of them, which means his total is 14. Oh no, here they come. Okay, I see oxygen. Boom. I'm going to grab this table. I'm going to find his red number. And I'm going to round that sucker off to a nice, easy 16. Ah, but now I see that there is a number to the lower right corner. I simply take that 3 and I bring it down here. And I'll multiply that 16 by 3. 16 times 3? 48. And then the last step is you adding. Just add them up. Heck, I don't know, is it 101? Something like that? 101? Thanks for your help. 39, 14 plus 48. Is it 101? Yes. Bam. And you would say, oh yeah, hey, it's 101 AMUs, atomic mass unit. This is a level 1 Pretty straightforward, no extra numbers. Okay, here comes a level 2 because we've got numbers in the lower right-hand corners. Now, let me show you level 3. No, I don't want to see level 3. Yeah, you do, because you're going to see 3 all semester long, suckers. All right, level 3. Level 3 is going to use your favorite symbol. What's your favorite symbol? Your favorite symbol is the parenthesis. Since you all love math, and you know math loves to use parentheses, and since we use math in chemistry to explain the world around us, we were going to have parentheses. We're going to have parentheses. Okay, I kind of wrote that 2 a little large. Now, look at the position of that 2. He's outside of the parenthesis, which means we're going to have to play that lovely math game of distribution. You're going to distribute this 2 inside here. Okay, I'll show you. Hang on. All right, man, I just start on the left and I work my way to the right, just like I did with this example up here. I'm going to start with that FE. I'm going to bring him way over here. Boom. First thing I do is I'm going to grab that element table. I'm going to find FE. I'm going to find that red number. I'm going to round it off. 56. I'm going to use 56. Ah, wait a minute. How many FEs are here? No. There's not 2 of them. This guy is not part of the parenthesis deal. He's outside of the parentheses, which means that does not go to the FE. Just look right here. Oh yeah, there's only 1 FE. There's his total. Ooh, now we're going to jump inside the parentheses. Now the game is going to change. Step number 1, the first thing I do, boom, grab your table. Nitrogen, there he is. Take that red number, which is the protons and the neutrons together to make up its mass, 14. Uh-oh. Now we've got a problem. I need to find out the total number of nitrogens, and that's where the 2 comes in because he's outside of the parentheses. So you're going to distribute this 2 inside. You're going to go right here and you're going to multiply it by whatever number is there. Well, there is no number there. Yes, there is. They just don't write it. There is a 1 there. So in reality, you're going to have 2 nitrogens. Because 2 times 1 gives you 2. You've got 2 n's in there, my friends. And if each n is worth 14, then 2 of those would be 28. Now that one's hard to see because you don't see a number there. You just need to remember, there's always a number there. They just don't have to write it. Uh-oh. Here comes the oxygens. Well, I don't care. It's the same steps, man. I'm gonna find this guy on the table, and there he is. I'm gonna take that 15.999999 and round it off to 16. Uh-oh. I have quite a few oxygens in this system, in this compound. Let me grab a different color so you can follow my eyes and where I'm thinking and looking. All right, so now what I do is I take this 2 that's outside the parenthesis and I go inside here and I multiply it by that. That is going to give you a grand total of 6 oxygens. Because 2 times 3 is 6, and each oxygen is worth 16 off the table. 6 times 16 is 96. Hang on, I'm going to double check my mental math. 6 times 16. Woohoo! Okay, 96. Good. Got them. Finally, add them. Total. Let's go. Add them up, my friends. Just add them up. 96 plus 28 plus 56. Boom. 180. Oh no, here comes my cat! Go outside. It's sunny outside. Okay, did I do that right? I'm going to double check my math. 96 plus, since you're not helping me, 28 plus 56. Yes, good. All right, so what would you do? You'd go, hey, Sticks, his molecular mass. Molecular. Is there an abbreviation for molecular mass? Yes, it's MM. You would say it's 180 AMUs. Yes, I see you. Yes. Questions? You are going to get sick and tired of doing this because this is what we use to help keep track of the properties of compounds and atoms. Because mass tells us a lot about how they behave. And humans love to quantify behavior, which means we put a number to how they behave. Which sounds weird and wrong, which it is. It's what we do. Your turn. You know how I do this. Man, I'll step you through things and then bam, it's going to be your turn. Because I can make things look easy. It's my job. But when you're on your own, you kind of go back and go, what did he do? I don't know how he did it. All right, so let's go. Okay, on your own, using your calculator and your second best friend. Oh crap, what am I on? Number 3 or 4? 4. 3? 4. 4! All right, come on. You guys can do this. Let's go. So, here we go. Let me give you, okay, hang on. Let's go with some magnesium. Okay, hey, we're going to have 3 magnesiums. Uh-oh, here comes some parentheses. And I'm going to put a 2 out here. Ooh, come on. You can do this. All right, my friends. Go. Calculate his molecular mass. Start on the left, work your way to the right, get the total. Step number 1, magnesium. Right off the bat, I'm going to grab this table. I'm going to find magnesium, and there he is. Good old magnesium. Hope you use 24. 24. But, hey, there's 3 of these. Because of that 3, I know that I got to multiply 24 by 3, which is how much? 70. How much? Thanks for your help. 24 times 3 should be 72. Yeah, 72. Boom. Done. Oh boy, now this thing is inside the parenthesis, which means I better be very careful to get the grand total of phosphorus atoms in here, and that's where I distribute that 2. That 2 times nothing, really, is 1. But the very first thing I do every single time, get the table, find phosphorus, he's right there, round off that red number to 31, use this 2 times it by the number that's in there, which is a 1, which gives you just 2 phosphorus atoms in this compound, and you get 62. Oxygens now, same thing, very first step, grab his red number, round it off, looks like 16. But boy, holy smokes, did you see how many we have now? I better use a different colored pen, holy cow. Hey, 2 times 4, you've got 8 oxygens in there. I'm not even going to try to do that in my head. 16 times 8, 128. That's just for the oxygens, 128. All right, once I got that part out of the way, at least the rest is a little easier. 128, I will add that to 62, I will add that to 72, and my grand total is 262 AMUs. Oh yeah. Yes. Somebody first period asked me a question like, so how do you really see there's 3 Mgs, there's 2 Ps, and there's 8 Os? Okay, this is what I did. This is what I showed that student. Watch this. Hey, I'm gonna do it. Hey, I'm gonna do it right over here. This, my friends, is the condensed formula. If I was to write this thing out in a long format, watch what you would have. Hey, I got 3 Mgs. I really have 2 PO4s. There. That's how that thing looks. And now you see why. They simply did this. Oh, well, guess what? There's 3 of those there. These seem to be very special packaged units. So they must be stuck together. And I see 1 of them and I see 2 of them. So I see 3 Mgs. I see 2 Ps, and I see, now there's 4 O's there, there's 4 O's there, there's 8. I don't know, maybe that'll help you see what this really is. It really is this. And once you see that, you then begin to see these numbers here in the totals. Okay, if that helps one of you, then I was successful. Okay. Hey, guess what? You're not done. We're now going to hit the major part of topic 4. This just leads up to the major part of topic 4. And so now you're thinking, oh my gosh, what do they do with this? Oh, sit down and watch this. What they want us to be able to do now for any compound is to apply a concept that humans love to use. Humans love to use percent. This is where you better pay close attention. Humans love to use percent. Why percent? Because percent is easy. It really is. Hey, you can tell a 3rd grader You can tell a third grader, hey, that pizza, 50% of that pizza is yours. And that third grader already knows, dude, I get half of that pizza. Or if you were at the store and you saw a 50% sale on some item, you would know right away it's half off. If you saw a sale 75% off, you'd go, oh my goodness, man, this thing is cheap. This is a heck of a good deal. I'm only paying 3/4 of what the normal price is. So percents are something that you can visually see. They're pretty straightforward. Hey, that new iPhone, dude, that thing is 25% off at Verizon. Okay, 25%. I get a quarter off. It's a quarter taken off the original price. I'm saving money. I hate to tell you this, but there is a formula for percent. There is one formula that everybody uses. Verizon, Fred Meyer, chemistry, economics. The formula for percent is really just this. That's it. I don't care where you are. You see percent, they use this formula. They use this formula. And all they do is it simply changes. These get more specific based on the topic that you're in. If I'm at the store and I'm seeing 60% off, okay, they're obviously using money. Money is what's going to go in here. This is what the original price was. This is how much they want to take off of that original price, which gives me the percent. So all we do is we just change these words based on what we're looking at. Okay, so I try to think of something that would be visual for this. And I hope this helps you. If it helps one student, I'm successful. I'm going to go home. Okay, my friends, look at this. Get out your calculator. Watch this. This is it's a whole bag of M&Ms. Now, you're smart. You know that within this bag of M&Ms, there's parts. Parts as in there's some green ones, there's some yellow ones, there's orange ones, and there's those nasty brown ones. I can apply this to the bag of M&Ms, and I can calculate the percent of like green, yellow, orange, or red. Okay, now watch this. Watch this. In this whole bag of M&Ms, let's see how many we really had. What was the whole? Which means now I grab the bag of M&Ms and I simply want to count how many we have. I'm gonna go here. I'll just put them in threes. Let's put them in threes so it's easy for you to count. All right, so in a whole bag of M&Ms, I want to get the total that are there. So watch how I change this. I'm going to change it now into M&Ms. And I'm going to count. 1, 2, 3, 4, 5 times 3 is 15. Dude, I've got 17 total M&Ms. There's 17 M&Ms in a whole bag. Simple, right? Okay, well now I'm going to pick one of these colors as the part that's in the whole bag and get the percent. Let's pick a color. Let's pick red. I want red. I think I scared my cat when I yelled. I want red. So what I'm doing now is the part that I'm interested in is the red M&Ms. And I'm simply going to count. What is the part in terms of just red M&Ms? Well, there's the part. 3 and 2 make 5. Red M&Ms. Oh yeah, hey, percent is always out of 100. So don't forget the 100. And that 17 goes there. Get out your third best friend, your calculator, and let's go. Looks like 5 divided by 17 equals, and we're going to times it by 100, and in my calculator, I get 29, and I'm going to round it. Now, wait a minute. You're probably thinking, whoa, wait a minute. What happened to the significant digit rule that you said we had to use? Well, you are using it. Did you count those M&Ms, or did you grab some tool from the drawer to help you determine how many are there? No, you just counted. When you count something, we don't use significant digits. So yeah, I'm still using the rules that I jammed in your face last week or so, just so happens are counted. That's not the way it's going to be the rest of the year. But for this demonstration, it is. So I see in my calculator 29.4, and it is percent of what? Oh, of red M&Ms in one bag. Because the bag is the whole. The part of the bag is the red. So this number here kind of depends on, okay, so how far do you want to carry it out? You want to carry it out to 29? Fine. You want to go to the 0.4? Fine. Does it matter? No. Why? They're counted. 20. Oh, I got a new bag. Well, I bet you there's like 29% red in here. Should I open it up to find out? Nope, I need that for period 4. That, my friend, is this. Okay, so now watch what we do, and then this is the end of part 4. What I do now is I apply this stupid formula to chemistry in terms of its molecular mass. Okay, so watch what I have to do. I'm going to eat these later when you're gone. So I'm going to save those over here. Okay, so watch what we're going to do now. We're going to use this general formula for percent, but now we turn it into something more specific based on the course that we're studying, which is chemistry. So now watch what I'm going to do. I'm going to take the part out because I don't want part. I want to be more specific. So I'm going to put in element. The whole, well, that's too general. I'm in chemistry now, and I'm going to replace that with compound. It's still out of 100. But what I'm trying to find is I'm trying to find percent by mass, which you know is the red numbers. What does this look like in terms of an actual problem? It would look something like this. Let's just make up a compound. Let's do this. Let's go potassium, and let's go 3. Let's go PO4 because you liked that last time. Okay, so I've got this compound. Hey, I got the compound. Now what I do is I have to pick one of the parts to measure the percent. So I just pick one randomly. I'm going to pick K. My job now is to find the percent of potassium inside this compound. I'm going to follow this right here. All right. Watch what I do now. How am I going to write this? Okay, I'll go this way. All right, I am now going to take the part and the whole and put them in their proper spots. What was the element of choice? Oh, it was K. How many K's are in there? 3. Just like there was, how many red M&Ms did we have? 2. Like we had 5 red M&Ms? Oh, we got 3 K's. Compound, well, that's the whole thing. That's the whole thing. Got it. Shoot, I don't see any numbers. Where's the numbers? That's where you go back to your topic 3 and 4 and you grab red numbers and you use them in here. All right, you know something? I'm going to have to move. Oh, shoot, I'm out of room. I'm going to move it down here so you can see it. There. I'm just going to enlarge it so you can see it. How do I find the percent of potassium inside potassium phosphate? I always start with the top. This guy right here. I'm going to start with him. And the first thing I do is I look him up on the table. He's right here. There's his red number. I'm going to round. Uh-oh. But hey, you've got 3 of those. Right off the bat, you have to, where's my calculator? You're going to have to multiply those things, man. 39 times 3. Cha-ching. Uh-oh. You got 117 sitting right there on the top. Why do I do the part first? I already know his total. I know the total on the guy in the bottom because I did him on the top. So I already know he's 117. I'm not going to do it twice. Phosphorus. Okay, again, the first thing I'm going to do is find P on the table. I'm going to round off that red number. I'm going to go back and look. Hey, how many P's are really here? There's only 1. Oxygen. First thing I do, table, red number, round. Second thing, I got 4 of those guys now. 16 times 4 is 64. Total, you better add them up. And I have no idea what that is. 117 plus 31 plus 64. Cha-ching! 212. That 212 is the total. Don't forget, percent is always out of 100. Okay, you are ready to go. Take 117. Divide that by the 212. Oops. 212. Times it by 100. And my friends, you're done. The answer that I get equals 55% of what? Oh, of K in K3PO4. Yikes. That's what we need to be able to do. See how fast and how quickly that snowball enlarged in topic 4 from the beginning to the end? it just gets nasty fast. All right, here's what I want to do before we leave. I just want to give you a very simple, straightforward percent problem. My goal, and your goal should be the same, I hope, is can you use this simple equation, which turns into this, on a very short example. That's it, okay? And this will let you know where you are. Let me get rid of this. I'll keep all that up there. Okay, let's go. Let's have some fun. Let's just do this. Let's go with, here's your last one. How about we try magnesium, and let's grab bromine. And I hate to tell you this, but it's going to be a 2 there. Oh, don't worry. You'll know how I got that later, and pretty soon you'll be writing these things. And let's pick this one. Let's pick the percent of bromine. Now, I want this to go fast. So I am going to give you the red numbers for magnesium and bromine to save you time. His red number is 24, and his red number is 80. Okay, with the red numbers provided, quickly find the percent of bromine in magnesium bromide. So I'm going to simply take my original problem. I'll break it down into these two parts, which I'm simply copying what I put in green. Once I have it set up, I am then going to grab some red numbers off the table and do my math like we did earlier. I'm going to place the totals in the formula based on what I have in green. I'm going to use my calculator. I'm going to get my percent, and I'm going to round it off. Man, if we were in person,